Good morning all, and welcome to a very damp electronics shed. So let's put the camera in its mount and fire things up. So today I want to charge some supercapacitor modules. Now I'm going to use my Muppet 2 board. I found the Nano, I found the software. I can PWM the buck MOSFET, and if necessary, it won't be for the first Supercap module. I can also PWM the boost MOSFET, so the output voltage can be higher than the input voltage. Now my power bank's a bit low, so I've probably only got about 11 volts coming in, but this one is only 2 Supercap, so it's 5.4 volts. We should be able to get that one energized up to its 5.4 volts using the incoming with just the buck MOSFET, which is this left hand driver module. We've got a blocking diode here, so it can't go back the other way. Not that that would matter particularly, I don't think, but anyway, let's get some current flowing. Now I'll turn on the buck MOSFET. We won't see any current for a while. The more green there is, the more this thing is on. What's that little glow? I think that might be a reflection off the board. So I'll turn this up and then we'll start to get some current. So let's put it at about an amp. In fact, for expediency, let's go up to about 2 amps. So the voltage on this thing will be coming up. I don't have a voltmeter on there, but it doesn't matter particularly. There are a couple of LEDs on that board, and when they start to light up, which we should see, we'll know that this thing's up to 5.4 volts. Yes, I figured that a meter probably would be useful, so I've put my DMM on the output terminals, which are directly across the capacitor. This flashing LED is getting quite nice and bright now at about 3 volts, but we've got a long way to go to take this up to 5. Now, of course, the current has dropped because this thing has no feedback loops, so I have to implement all the feedback. So if the current starts to fall, I have to turn the PWM up a bit to boost the current back up. So let's take it back up to 2 amps. The voltage on the cap bank starts to increase more rapidly, but this will fall down again as the capacitor voltage comes up, and therefore we need more PWM percentage to maintain this current. That's already dropped back a little bit. Let's put a little bit more on there. Okay, 3.5 volts on the capacitor bank. This I'm using as a sort of faux security system. It's just a flashing red LED, but it runs for a couple of days on these 2 capacitors, so it's quite useful. Okay, what's that? 3.6 volts. Let's just let it run for a bit. 4.2 volts now. Just edge that current back up to 2 amps. I mean, there's nothing stopping me going to 3 amps, 4 amps, or even off the scale. What's that taking out my power bank? 60 watts out of the power bank. Oh, that's taking up to 4.8 volts. That's good. Closing in on the 5.4 for this dual supercapacitor block, and then the 2 little red lights should light up. That's 3 amps, 4.9 volts. If I keep watching this, I can use these high currents, but of course as soon as the first capacitor reaches its top voltage, I should back this off. 5.2 volts. Now one might come up before the other, so I will drop the current down to an amp and a bit. That falls away a little bit to start with. The simple pressure of all that current flowing in pushes its voltage up. Drop the current back, and although that's still charging, its voltage actually falls. Interesting. 5.2 volts. And I got the first of the lights coming on now. This LED here is coming on, and in fact I can steer the current by using that LED in the feedback loop. So if I edge that back a bit, the second one is behind this big flashing LED, you can't see it very well. In fact, it would be more sense at this particular moment in time to take this flashing LED off temporarily, so we can see that the 2 LEDs on the board, I'm going the wrong way with the pot, yeah, so I can steer those by the amount of current I'm pushing through to either illuminate them, I'll bring them up high, or turn them off. They're not very easy to see under these lights, are they? But anyway, that's that thing charged up. Both these lights are on. We got 5.4 volts at half an amp. I can leave this on half an amp continuous because these protection circuits can offset about half an amp. But yeah, that one's charged, so I'll back that right off. So that's my faux security light charged up. So yeah, that'll look good in the window of the shed. Okay, let's put that one up there. Right, the next one I want to charge is this one. Now this one has got 4 volts on it already. This is a bank of 6 120 farad, I think they are, 2.7 volt capacitors. I'm trying to standardize on using these 4mm terminal posts as my connection interface for the supercaps. This one had a couple of extra points on it, so I've also got this analog voltmeter. So let's hook that one up. So now we can watch the digital voltmeter and the analog voltmeter. They're in reasonable agreement, about 4 volts. Now we can get that up using just the buck MOSFET. Let's get some current flowing, so let's get an amp flowing. That will start pushing that up. But because this module is 16.2 volts and I've only got about 11 coming in, I will, in order to get this thing fully charged, and we'll see this one really clearly because it's got blue LEDs which switch on and switch off rapidly. It's not like the protection circuit on here where it's kind of linear. The higher these go around the 2.7 volt mark, the brighter that light is. On these ones it's digital, so the blue light will just switch on, apply the protection circuit and then switch off. And in fact, if you leave half an amp flowing through it, the blue lights work a bit like this thing, where they're just randomly flashing on and off. Right, we've got no current now, so as the capacitor voltage has gone up, we need to keep increasing the PWM. You can see that we've got some red and green, can't see the red on that very well, some red and green on the buck PWM, so we're still in buck mode. That's dropped back from an amp. We've got no green on the boost driver module, so the boost MOSFET is not being used at the moment, but it will need to be because, as I say, the voltage of this pack is higher than the incoming voltage. Let's keep that up to an amp and carry on pushing that up. In fact, let's give it more. Let's give it, oh no, didn't like that. Why didn't it like 3 amps? That's interesting. Got a funny discontinuity. Probably actually the incoming voltage is more like 10 volts and we're getting close to 10 volts, and so we're at 100% buck PWM and still only got half an amp flowing. We now need some boost PWM in order to take this into the range above half an amp, and that has pushed us up to 10 volts. Let's keep. Now the boost MOSFET gets a lot hotter than the buck MOSFET. There's probably a reason for that. I can't think what it is just at the moment. So I probably won't go over a couple of amps while I'm doing boost PWM. But yeah, up to 12 volts, waiting for 16 odd. So I was just trying to push it up to 2 amps and feel the temperature of the boost MOSFET. Yes, that's really warm. I did buy some heat sinks for these, I must fit, particularly the boost MOSFET really does need a heatsink. The buck one never seems to get particularly warm. But let's carry on pushing this up to 16 volts, 15.6 there, couple of amps. I won't go any higher than that. We've got one of the protection circuits come on, so I'm going to back this down to about half an amp, and then the protection circuits on here can cope with that current. And then we'll just watch and wait for all the other capacitors to come on, which is going to happen at around 16.2 volts. So let's just leave that for a while. In fact, what I'm going to do is time lapse this and speed this section up so that you can see these LEDs coming and going. So we're up to voltage. All the capacitors have probably had their protection circuits come on now at one time or another. It's very twitchy, the potentiometer at this point in the boost position. I don't know whether that's humidity here in the shed, or I know that the buck, this is jumping about all over the place, very hard to keep it at 0.5 amp. I know that the buck takes 2/3 of the pot range. Ooh, suddenly shot up to 1.5 amp. I'm not sure whether that's perhaps a good thing. Maybe I should allocate more range to the boost. The boost at the moment only has a 1/3 of the pot's full travel. Maybe I'll allocate them equally. The boost driver is only allowed to go up to 50% because of course you don't want to turn on the boost MOSFET, which is this one, which effectively shorts positive to ground. You don't want to turn that on 100%, so it limits this. You can't go higher than 50%. But we're up to voltage. These caps are switching on and off. Let's go to the next SuperCap module. And that's this one. It's got 9 of these 100, are they? 100 farad, 2.7 volt SuperCaps. This one's got a couple of light bulbs on it just for fun. Well, also because I had to have something which would sit across 24 volts, because that's approximately the voltage on here, that wouldn't blow. So let's plug that one in. And now, of course, this one's going to require more from the boost functionality of the Muppet 2 board to get it up to voltage, but it's going to be not many volts at the moment, so the ammeter should come on fairly soon. So let's give that a couple of amps, and the voltage is, oh, less than a volt. Yes, it would be 0, wouldn't it, because I've had this resistance across there which has pulled it down to 0. Absolutely 0. Oh, current's dropped right off, so let's give that some and keep increasing it to keep the current flowing in there. These bulbs should come on at some point. Let's push that on up to 2 amps. We're still in buck only mode, so we're only driving the buck MOSFET. Let's push that up. But at some point, of course, we'll need to go into boost because, as I say, I've only got about 10 volts coming in. I need 24 on there. Right, approaching 10 volts on the meter, and I've run out of buck mode functionality. So in buck mode we've got virtually no current. I'm going to have to take it into boost territory. So now this MOSFET up here is 100% on, green only. That's slightly warm, that one, from doing the buck process. Green only here, so that's 100% on. A bit of red and green, so this one is oscillating. 15 kilohertz. You might be able to hear it actually. Some people can. I can't. So let's get some boost going on that. I won't go above 2 amps because I know that's not good for this MOSFET. But I've got to push on now. And I can imagine turning this pot up absolutely full in order to get enough boost functionality that we can get the voltage on this capacitor bank up to 24 volts. Let's keep pushing current into that supercapacitor. 2 amps. Nice, but it does keep falling back. These lamps are getting a little bit brighter. 13.5 volts. I'll keep that going. I've reached the maximum position on this pot. It's right at the top of the shop. Now that means I've got 50% duty cycle on my boost driver, which is driving this MOSFET. That's switching on and off at 50% duty cycle. The current is falling because the voltage on the cap bank is coming up, and yeah, this is going to struggle to get up to 24 volts. It might work better if I take these bulbs off. In fact, I think I'll do that because we can't really, there's no perceptible change in brightness there. So let's take those off. That should assist this thing pushing on up towards 24 volts. Now I can't remember what the lights on this are. I think these are more of an analog protection circuit board, so we're not going to get them suddenly coming on bright. They're not particularly bright. I think they're red, but yeah, I'd like to see some of those red LEDs coming on to show that we've got a capacitor at least up to its full voltage, but I've got no more adjustment on this pot, and therefore I'm limited now in how much current I can push into that. One way I could do it is to put more voltage on the input, but the power bank's actually pretty low on juice at the moment, so it's probably down around 10 volts. Actually, I might as well run the camera here. I'll do another time-lapse speed up in post-production. That basically means Microsoft Movie Maker, as this pushes on up towards 24 volts. Whether we get there or not, because we've only got about 300 milliamps now, and how long it takes to get there is another matter, of course. In case you were wondering, this ammeter is actually plugged into the ground line, so the current is actually flowing that way, but for some curious reason it indicates current in that direction if it's flowing that way. So I thought by putting it in the ground line, then I'd at least have the needle pointing in the direction of current flow, and it's convenient. It sits across those two posts. The inductor, of course, is sitting in the positive line. I don't think we're going to get much more out of this, to be honest, with the low voltage that I've got on the input. If I could raise that up, I could probably push this higher. So I don't think we're going to get any of these LEDs coming on today. About 20 volts on that cap bank, and there's really so little current flowing in there. That's about as far as we're going to go. So I think what I'll do is I'll reattach my bulbs, because I might as well get this capacitor bank to do something. It's just going to light those lamps. But yeah, that's me finished, I think, for today. I did the 5.4 volt dual 500 farad 2.7 volt supercap bank. Also did this 6, I think it's either 120 or 100 farad. What is it actually? Can't see on there. No, I can't see. It's 100 or 120 with analog voltmeter, and the 24 volt 9 supercap bank all successfully charged up. So that's it. Cheerio.